A person is invited for two different functions at the same time. Is the presence of him possible at both places? Obviously no. Every person has a unique identity and cannot be present at two different places at the same time. How can we relate this to functions in sets? A function is a subset of the cross product of two non-empty sets, A and B, such that every element of set A has a unique image in set B. Let's learn more about functions and terms related to it in this video. We have plotted points on a graph paper. The points are given by their coordinates 4, 5, -5, 4, -3.5, -4, etc. We know that the first number gives us the x-coordinate, that is, the distance from the origin along the x-axis. And the second number gives us the y-coordinate, that is, the distance from the origin along the y-axis. It is for this reason that if we change the order of numbers, we get a different point. 4, 5 and 5, 4 are two different points. Such an arrangement of pairs of numbers where order is to be retained is called an ordered pair. The cross product of two sets, A cross B, is the set of ordered pairs AB such that A belongs to A and B belongs to B. To explore all possibilities, let us have two sets. Set A with 5 robots and set B with 7 bikes. Now we pair a robot with the bike matching its color. Case 1. Green robot with green bike, blue robot with blue bike, etc. In this case, we find that each robot has only one bike to itself. Case 2. Let the bike with orange color be replaced with the bike of light green color. Now we find that the robot with orange color does not have a bike to itself. Case 3. Take the bikes of light green and purple color and replace them with orange colored bikes, matching the sets again. Now we find that the orange colored robots have two bikes to itself. Thus, we observe that in the first case, each robot from set A has a bike to itself and there are two spare bikes. In the second case, there is a robot without a matching bike. And finally, in the third case, we have a robot that has more than one matching bike. These conditions lead us to the definition of a function. A function is a subset of the cross product of two non-empty sets, A and B, such that every element of set A has a unique image in set B. The function is represented by small letters. For example, function f is A to B. Set A is called domain and set B is called the codomain. This further implies that no element of A can have more than one image in B. And there also should not be any element of A which does not have an image in B. Mathematically, it implies that no two ordered pairs will have the same first element. Let us consider another illustration for better understanding. Set P is equal to A, B, C, D, E, F. Set Q is equal to 1, 2, 3, 4 on to 10. Function is a subset of P cross Q. Here, F is equal to the set of ordered pairs X, Y, such that X belongs to P and Y belongs to Q. where y is the order of the alphabet. That is, f is equal to the set of ordered pairs A1, B2, C3 up to F6. The set of all the points of codomain which have a pre-image in domain, that is 1, 2, 3, 4, 5, 6, is called the range of the function. In this case, we remove the elements 7, 8, 9 and 10 from the codomain, which do not have a pre-image in the domain. If set Q is equal to 1, 2, 3 up to 6, then all the elements of set Q have a pre-image in the domain. And in such a case, the codomain is itself the range of the function. To summarize, in this session, we've learnt and understood the concept of a function. In this video, we understood the concept of a function. Now the question arises, can two functions be equal? If yes, then on what condition?